Course 1, today we're going to make these prime number fractions a little easier by canceling out top and bottom, and then we're also going to divide fractions by fractions a little bit today. Let's start. You've had these problems before where they look like this. To make it quick and to quickly reduce what this equals, match up numbers when they're being multiplied, right? That's what this is. Match up the numbers that are the same, only crossing one out once. You're left with a 2 that has no pair and a 3 that has no pair. So the 2 stays on top and the 3 stays on the bottom. The book does a nice job of visualizing why that's okay to do for math. See, what we're really doing is grouping the 2's here that are 2 top and bottom really means 1, and 1 times anything stays the same. So if you have a 2 over a 2, it doesn't change the product. That's why it's important that we're multiplying right now. If this was addition, you couldn't just cancel out 1's. That changes the value. But 2's over 2 is 1, and 1 does not change the value when you're multiplying. So these are really just 1's until you get to the ones that don't match, the 2 over the 3. So that's how you're going to solve those, whether you understand it or not. You can make some matches and tell me what's left pretty easily. If I were left with more than 1, like let's say we were doing 2 times 2 times 2 over 2 times 3, a little different that time. So now we would cancel out our matching 2. That's all I've got. I would probably want to multiply these together then in my answer and call my answer 4/3. How can I convert that? 3 goes into 4 one time. 3 goes into 4 one time, leaving me with a third left. Okay. Review, if I were dividing 10 by 5, I know the answer is 2, but what I'm really asking is how many 5's are in 10, am I right? If I have a 5, how many of those does it take to get to 10? In this case, it comes out even, right? If I have another 5, that's all going to, in the end, put together equal 10. How many 5's did it take? 1, 2. That's what I'm saying. I can do it with fractions too. I would never show division of fractions this way, but it can help you compare to what we do know. If I'm dividing 3/4, which is bigger than half, and I want to know how many halves fit in there. Halves look like this, right? How many of these fit? We can see right off the bat, 1 fits for sure. But the problem is this right here. It's not going to be exactly another 1. It's not going to come out even, and we've done mixed number quotients before, but it's maybe harder to imagine when you're dealing with parts. So now in this part, I'm asking what part of a half is that? If I look at this closer, it's this much. How much of a half is that? We said a half looks like this. Right, just flipped around. Looks like about a half of a half. So I think our answer ends up being 1½ when we're asking how many halves are in 3/4. They do a nice job of explaining what I just showed all in this 2-step process here. If you want to read through it, it goes a little bit slower. Gives you visuals for more steps of the way. But to review, it asked how many halves are in 3/4, which can be shown this way. The way we actually solve, I just did it with pictures, but you're not going to be able to do that. So actually, step 1, the review of what the book has us do, is you have to find out how many halves are in 1. Or how many halves does it take to get to 1? 1 whole. How many halves, how many of these does it take to get to 1? Right? Okay, so what number would I fill in there? It's always going to be the reciprocal. 2 halves is 1, right? Now with that 2, I multiply by it by the number I was trying to get to, the 3/4. That comes out to 6/4, which we learned last time can be first converted, 1 2/6, then reduced to 1 1/3. Uh-oh, that's not right. I did something wrong. This should have been a 4 here, not a 1/6. Right? This should be 1 2/4 because this was a 4. Even teachers make mistakes, and I'll keep this in here so you know. And then 1 becomes, or answer becomes 1 1/2 reduced. So we converted, and then we reduced. Again, the steps, find out how many halves are in 1, which was 2. Then use that to multiply by the number we were trying to get to before, 3/4. That tells me how many halves are in 3/4. So it's a good little process for you. If you think about it, it all makes sense what we just did. Maybe again you read through this explanation. That's where it tells you why we're doing what we're doing. If you're just a memorize the process kind of person and you don't want to get into that, you could also just learn these 2 steps and follow them religiously. Find how many of the divisor are in 1, then multiply that amount by the dividend. You can actually flip this around if you didn't see ahead of time. I've actually got it ready for us here. Now I'm going to divide half by 3/4, and wait. 3/4 is bigger than a half, we said when we were looking back at this. Can you really divide by that? Well, just like I divided, just like you can divide 3 by 6, even though 6 is bigger, and find that it's 0.5, we can divide a number that's smaller by a number that's bigger. It just means we're going to say it's less than 1. 3/4, how many 3/4 are in a half? Right, we said 3/4 looks like this. How many are there in a half? Well, it's going to be less than 1. How many of that is in 1/2? This much of 3/4 is in 1/2. And how do we decide how much to 3/4 that green amount is? We're going to follow the same process. How many 3/4 are in 1? The reciprocal, always use the reciprocal. Then use this times the dividend. 4/3 times a half. Do some canceling if we're getting good enough at that. And I find 2/3 is the answer. So find the reciprocal of the divisor and multiply it by the dividend. Make sure you convert and reduce as needed, and you've got your answer for these. Don't be afraid to pause and replay any of this video. I'd like you to do letters B and C and show those to me before lunch. Thank you.